Alright, I'm gonna give you my version of trying to attempt to solve for why there is no odd perfect numbers. I just figured out uh, I didn't write that sentence good. But anyways, yeah, perfect numbers. I'm gonna tell you that there are no odd perfect numbers. And one of the reasons why I should probably point out there is no odd perfect number, it is the most obvious reason out there. And if it wasn't for a 2,000-year-old question, I would actually think it was a trick question that nobody has already. Or I don't know. There should be somebody already that would have noticed by now. But anyways, let's move on. And the answer is most numbers that are odd are prime numbers. You guessed it. Prime numbers, interesting numbers that appear all the time, and they're not divisible by two, so they don't have that many divisors. Actually, that's probably one of the problems of odd numbers is that they're not divisible by two. Ooh, by two. They don't have that many divisors, so if you're trying to prove something is a perfect number, then it's not gonna work out because there are odd numbers don't divide evenly. Um, Other properties of odd numbers is that yeah, they don't have that many divisors. So let's move on. And prime numbers make it not perfect. Okay, so to me, this is the formula that I think why prime numbers are never gonna be perfect numbers. To me, they are. See, prime numbers are mostly divisible by themselves or one, so they're not gonna be divided equally into an even number, and they're not gonna be divided equally into an odd numbers, or an odd number cannot divide a prime number. So when it comes to perfect numbers, uh, I think I still got this right. I think I'm doing it right because um, this is why when it comes to prime out there, and if you're gonna prove that an odd number is a perfect number, then that's probably why it's not gonna be a perfect number. And yeah, and there is a cherry that I'm gonna throw out over there. Cherry on top of this problem is that uh, number one. If you can prove that number one is perfect number, you could actually prove that there's a larger odd number out there. But because one can only be divided by one, so uh, one can only be divided by one. So uh, you have a divisor, and then you have I forgot this, forgot the name of it. You have a divisor, and you have this other, and that divided. I'm just gonna say that divided. So if you only have one, and you can only divide it by one, is it gonna give you a two or one? That's usually the question that I'm asking. Because usually, if you can prove without a fact that because one is odd, and you can prove that it's a perfect number without a doubt. I have doubts if it's gonna be a perfect number, but anyways, and that to me, that's why I think it's a trick question, because that's probably why it should been thrown out over there. So here's some of this stuff right here. I'm gonna blank out there. I'm just gonna whatever. Let's just talk about it. Okay, so when you try to do, try to make your list of what could be potentially out there, this is what I'm trying to tell you. So number 3, actually it's a prime. So if you're trying to prove, it's gonna give you a 4. If you're gonna prove it's a perfect number. The one that's closest is number 9, and you can only be divided by 3. So the divisors are only 3. Gives you a 7. It's pretty close. It's a pretty close number, but yeah, you can probably try to do it. I think I'm doing it right. So somebody out there will probably correct me or something, but never mind. Yeah, and the one that's closest gives you a 7 too. That's pretty weird too, because it gives you the previous prime. And then you go 11, 13, and then you get to 15. See the same problem. The divisors are not, the sum of the divisors are not really high enough to make a 15. So the many if you can get, well, if like divisor are kind of like the same factors, so you can only have like they only have like yep, they only have one factor. If you're gonna factor it by 2, the root 2, then you don't have a duplicate there, so you can put it out there. It's factorial, so gives you a 9. So actually gives you, I believe it gives you a 9. So I'm doing it. I'm doing it right. So 17 is a prime number, so that's not gonna work. 19 is a prime number. 21 also the same thing. You get into you still get into 3 digits, so it's not gonna be something close, because about half. See, for me, going to this list, the divisors don't get high enough to make up the sum of the odd numbers. So perfect numbers were like somewhere around 6, because 2, 3, and 1. So 2 times 3 is 2 times 3 is 6, but then it will also be divided by 1, so you got that in there. And yeah, so it doesn't work if you try to make it, because most of it, if there would have been an obvious number, it would have been the low in the lows odd numbers, so it wouldn't be in the double digits, because once you get into double digits and you don't have enough divisors, it doesn't add up. See, so I wrote not enough divisors. So I guess if there's going to be a large number out there that you can probably prove with a computer, there's going to be a bunch of primes that it will show up, because usually either it's going to be like 2, 3 primes of the same sum or something like that. I just don't have enough time really just to try it at least to 100 just to make it. I could, but that'll be for another video, and probably somebody else would probably already, oh no, this guy's, they're probably gonna say, oh yeah, it's an accident, he's been spying on us, I'm gonna do it first. And I don't know, I'm gonna do a video if I can get a list of, if I have time before the weekend to make a list and do a second video, because I don't know how to edit stuff. So it should be pretty just easy. Just me, just talking about this and just posting it in there. I just want to do another number video because this looked like it was gonna be like the easiest um solution out there. And I was gonna throw another cherry too, because usually with prime numbers, if we're talking about prime numbers right now, and yes, I'm on the floor. Usually, if you're talking about prime numbers right now and perfect numbers, if you add probably a -1, you can probably make it a perfect number. Yeah, I got hair here. Yeah, you could probably make it into a perfect number. But if we're throwing negatives, because usually you don't want to throw negatives in there, and that's another cherry for everybody else to think about. Yeah, I'm just not gonna say the I'm just not gonna say publicly the answers of the cherries because don't know. So I think I know particularly why you don't want to throw a negative in there, but uh yeah, that's probably the two cherries that I think will probably say, well, either prove that it's a perfect number. I mean, if you try and make primes your perfect numbers, then yeah, go ahead. That's probably the easiest thing you could probably do is just throw a negative. But then you're gonna get into the negative loophole, and then for some reason, for those, and this is a joke, so if you get crazy with this, you're probably gonna start throwing I, and you're gonna be like, yeah, if you put an I on this, it's gonna be a perfect number. So I don't know. And number one, yeah, that's usually the big question that I don't. The big if number one is a perfect number, then there is possibly a very large number out there with probably a computer, but I'm not a computer scientist, so they probably name a star after you if you find it. But yeah, that is my attempt to solve this problem. I don't know if there's another guy up there that probably would have actually done this and read a paper on this, because by far I think this is probably like I was meditating this while I was working at work and packaging some boxes on Amazon. So yeah, it took me probably like I work night shift, so it took me the whole night just be thinking about this. So yeah, um, um, and that's what I got right now. And I think those were the main bullet points that I wanted to point out. Why I think there's no odd perfect numbers. But you could probably just take a guess if you want to prove that negative. If you throw a negative in there, yeah, I know you're cheating, but you're like so another cherry for people over there who are obsessed with this problem, I guess. So if you can probably prove that you can put a -1 in there somewhere in your mathematical mind, go ahead. And number one, if number one's a perfect number, yeah, I wish. So I will leave you to that and something to think about in the near future. Um, yeah, eventually somebody will probably give me a Nobel Prize. Just joking. Adios.